We often hear about faults when we talk about earthquakes, those shaky times that remind us of the huge power under the ground. The ground beneath our feet is constantly in motion, even though we might not feel it. These movements are caused by the shifting of tectonic plates, massive slabs of the Earth's crust that float on the semi-fluid mantle below. But faults do more than just cause earthquakes. They're like hidden artists, shaping the world around us. These fractures in the Earth's crust are responsible for creating some of the most breathtaking landscapes on our planet. From tall mountains to deep oceans, faults help make the exciting landscapes we see. The majestic Himalayas, for instance, were formed by the collision of the Indian and Eurasian plates. Similarly, the deep ocean trenches are the result of one tectonic plate being forced under another, in a process known as subduction. These cracks in the Earth's surface are always moving, even though we can't see it. The movement is slow, often just a few centimeters a year, but over time these small shifts can lead to significant geological changes. Over millions of years, these tiny movements add up to big changes, creating the amazing things we see today. The Grand Canyon, for example, was carved out by the Colorado River over millions of years with the help of tectonic activity lifting the region. Understanding faults helps us understand how the Earth works, its history, and even what might happen in the future. By studying these geological features, scientists can predict potential earthquake zones and help communities prepare for natural disasters. The story of faults is a story of the Earth's dynamic and ever-changing nature. Imagine the Earth's surface is like a giant jigsaw puzzle made of big pieces called tectonic plates. These plates fit together, covering the entire surface of our planet, much like the pieces of a puzzle. Each piece or plate is constantly in motion, albeit very slowly, driven by forces deep within the Earth. These plates are always moving very slowly because of the heat from the Earth's core. The core's intense heat creates convection currents in the semi-fluid mantle layer, which in turn causes the plates to shift. This movement is usually so slow that we don't notice it in our daily lives, but over millions of years, it can lead to significant changes in the Earth's surface. This movement creates a lot of pressure where the plates meet. As these massive plates grind against each other, they can get stuck due to friction. When they are stuck, the pressure continues to build up over time. This pressure is stored energy, waiting to be released. When the pressure gets too strong for the rocks, they crack, making a fault. This sudden release of energy causes the rocks to break and shift, creating a fault line. The process is similar to snapping a twig. The built-up tension is released in an instant. It's like bending a stick until it breaks. The energy that was stored in the stick is released all at once, causing it to snap. Similarly, the energy stored in the Earth's crust is released when a fault forms, sometimes causing earthquakes. This break is what we call a fault. Faults are fractures in the Earth's crust where blocks of land have moved past each other. They can be found all over the world, often marking the boundaries between tectonic plates. Faults can be short, just a few meters, or thousands of kilometers long, crossing continents and going deep into the Earth. These geological features are crucial in understanding the dynamic nature of our planet and the forces that shape its surface. Not all faults are the same. Depending on how the tectonic plates push or pull, there are three main types of faults: normal, reverse, and strike slip. Each type makes a different shape on the land. Normal faults happen when rocks are pulled apart, so one piece slides down. Reverse faults happen when rocks are pushed together, so one piece goes up on top of the other. Strike-slip faults happen when rocks slide past each other sideways. The slow movement of faults changes the Earth's surface. Normal faults, where rocks slide down, make valleys like the East African Rift Valley. Reverse faults, where rocks push up, make mountains like the Himalayas, where India crashed into Asia. Strike-slip faults, where rocks slide sideways, can change the direction of rivers, make straight valleys, and even cause earthquakes when the pressure gets too high and suddenly releases. The San Andreas Fault in California is a famous strike-slip fault known for its big earthquakes. Faults also help make oil and gas. These important resources get trapped underground because of fault movement. Oil and gas move up through rocks, but sometimes they get stuck under layers of rock they can't get through. Faults can block the oil and gas, creating traps where they collect. Knowing where faults are is important for finding oil and gas. The North Sea has lots of oil and gas because of faults that formed millions of years ago. These geological faults are essentially fractures in the Earth's crust where rock has moved on either side. Over time, organic material was buried and subjected to heat and pressure, transforming into oil and gas. The faults acted as pathways, allowing these hydrocarbons to migrate upwards until they were trapped by impermeable rock layers, creating reservoirs. These faults trapped the oil and gas as it moved up. Without these natural traps, the hydrocarbons would have continued to the surface and been lost. The process of trapping is crucial for the formation of economically viable oil and gas fields. This is why understanding fault systems is essential for energy exploration. The Ghawar field in Saudi Arabia, the biggest oil field in the world, is also next to a big fault system that trapped lots of oil. This field has been a cornerstone of global oil production for decades, providing a significant portion of the world's energy supply. The fault system here is complex, with multiple layers of rock creating numerous traps for oil. The Permian Basin in Texas, another place with lots of oil, also has many faults that trap oil and gas. This region has seen a resurgence in oil production thanks to advances in drilling technology, such as hydraulic fracturing and horizontal drilling. These techniques have unlocked previously inaccessible reserves, making the Permian Basin one of the most prolific oil-producing areas in the world. These examples show how important faults are for the Earth's energy. Faults not only create traps for hydrocarbons, but also influence the distribution and accessibility of these resources. Understanding the geology of fault systems is key to finding and efficiently extracting oil and gas, which continues to be a vital part of the global energy landscape. Faults show us that the Earth is always changing. They're like artists, making mountains and valleys and even affecting where we find oil and gas. By studying faults, we learn about the forces that shaped our planet over millions of years and are still changing it today. This helps us understand earthquakes and how to use the Earth's resources carefully. By learning about what's happening under the ground, we can better understand our amazing planet and our place on it.